Okay, I think we're ready to get started. Dieter, you ready?
I'm ready, yes.
Excellent. All right, so welcome to the NTP working group at IETF112. We have 1 hour today, so we're going to need to be pretty efficient. Starting out, we have, so I believe Dieter is planning to take minutes. If anybody wishes to help him, that would be great. Also, if there's any volunteer to pay attention to the chat log, sometimes I lose track of the chat depending on how much conversation is going on. So if we could get somebody to pay attention to that, it would be helpful. Also, this is the IETF Notewell that you will have seen many times. This is all of the rules and processes and procedures that we follow. We have a couple of online meeting things to remind everybody. As a reminder, this session is being recorded. Also, the chat is recorded. So you just need to remember that. These are the basic reminders for an online meeting. The one thing to note is that the blue sheets are now automatically generated by Data Tracker. If you have any additional questions, you can find that information there. The next slide is a reminder about the IETF Code of Conduct and some of the key points associated with that. The main one being to be sure that we treat everybody with respect and courtesy. And so with that, we will move on to the agenda. This is the administrative and agenda bashing portion of the agenda. Do we have any agenda bashing to be done? Nope. Okay. So the next slide begins our discussion of various working groups, document status and review. Things that we don't necessarily need to have presentations on today or discussion on today, but just to remind everybody of where we are. We have been working through an updated charter that's currently out for external review. The link to that draft charter is shown there. As I think Eric noted in the chat, we're rechartering. We're also very slightly changing the name. We're changing it from Network Time Protocol to Network Time Protocols, and that way we can keep the history of all of that. It also gives us the approval in the charter to do things like rough time and some of the PTP associated things that we're working on. Next on the list is the Mode 6 commands, which has been languishing for quite a while. It went through IESG evaluation. There was some, if you will recall, some discussion on the historic versus informative status of the document. There was a resolution to that, and as of about, it's awaiting an update from Brian. I communicated with him earlier today, and he expects to have a update out very shortly. The next one is the Yang model, which is also an IESG evaluation awaiting an author update. I know Dhruv had hoped to get that done by Monday, but the reality of an IETF week has intervened. Dhruv, did you have any update you wanted to give, or are you?
Yeah, hi, it's on top of my queue. I will handle this just post IETF for sure.
Okay. Great, thank you.
Thanks for your patience.
Oh, believe me, people need to have patience with me, so I'm happy to have patience with others. Speaking of patience with me, the interleave mode is in IESG evaluation. It's been deferred, and it needs some guidance from Eric. It also needs the correct write-up, which is one of the things waiting on me. I don't know that we need to say much more about that. The next document, I just put this one in this list because we will be finishing it up and then moving further discussion to NTP, to the NTP working group, is the PTP enterprise profile. There was a small update to that done, and it's ready to go to the IESG. It's awaiting a write-up. And one of the things in particular that it needs to reference now is the ongoing IEEE effort, IEEE 15888 effort to address terminology. So we know the terminology in this document is going to be a little bit problematic, but it's IEEE 1588 is already working on that issue, and this will just point to that activity. Alternative port is in working group last call. We did not close out that working group last call. There has been some discussion on it. Is there anything anybody wants to say about that here? I think it's really up to Dieter and I to close out that working group last call and determine next steps, which we haven't done yet. Go ahead, Eric.
Yes, you'll probably note that I sent Magnus will do a early TSV area review for the port allocation bits.
Oh, right. So, excellent. I did note that you had sent that. I forgot to mention that had been done.
I'm hoping that we don't get told that ports are old news. Everything is ALPN now, but anyway.
Yeah,
we'll see.
So the Kronos document was updated in August, but there has been very limited discussion on it. I don't see any of the chairs here, any of the authors here, I don't believe. Looking through the list again. So this has been adopted as a working group document, but progress on it has slowed down. I think the next step is probably for Dieter and I to reach out to the authors and see if we can get this to the point where it is ready for a working group last call. Figure out what the next steps for that document are. The next document that we don't have is the NTP update registries. Rich did submit an update to that, and he suggested to the mailing list that it was ready for a working group last call. I don't see Rich on this in this meeting. I believe it can be moved to working group last call. Is anybody that does not want to see that done, or is there anybody who thinks some additional discussion is needed on this document prior to working group last call? No. Okay. So that's the all of the documents that in the sort of quick document status review update section. The next part of the agenda is rough time. Rough time is next. So, Watson, do you want me to share, or are you going to share your slides?
The slides, that would be most appreciated.
Okay. I shall do that. Rough time.
Just a special slide. Well, we'll make it work.
Yeah.
So This is rough time at IETF 112. And the next slide has the things that we want to talk about. So I'm going to start by recapping the problem we want to solve. So this is for cases where you have time that needs to be accurate in a few seconds, hopefully less, but that's what's very guaranteed. And the reason we need this is for things like certificate validation. 30% of certificate errors are caused by inaccurate client clocks, and getting rid of that would be a very big boost to user security. There's other applications. That's sort of the problem. And so we have a whole laundry list of issues that came about during the pretty active discussion on the list the past few weeks. We haven't had a chance to turn this around into a document update. And there's another whole slide of issues. So all of these issues, we have some conclusions about. We think, it's on the next slide, that most of them are editorial. And we'll move to milliseconds everywhere. We're going to change, that's going to affect the size of the fields. We'll see if that gets it down to 32 bits. It might not. The comparison to RFC 3116 or whatever it was is, you just write a section. It's not a problem. But some would deserve more discussion because they're maybe a little more contentious. So the first thing is the SHA-512 only. There was a debate about whether or not we need another hash function. The reason we want this is cross-protocol signing is bad. You really don't have any guarantee of security when you're using the same key two different ways. Edge 5519 uses SHA-512 internally, so you're not paying a penalty in code size for it. We also need to have, we ideally have a very high degree of support. If people point to PKIX as an example where you have all these things supported, you don't. Because what actually happens is the CAB form has very restrictive rules on what can be signed. And they have it for the same reason. Browsers don't want a situation where some CAs are working with some browsers. They want to have a very uniform playing field. And as for the question about accelerating rollout, you don't really have accelerated rollout if you have sort of an identifier versus a new version. It just doesn't, this is experience in TLS. It takes a while, no matter what you do. Now, there are some counter arguments that sort of the extensibility piecewise is good, and that the cross-protocol attacks are more theoretical than real. And those are fine arguments. And hopefully after this presentation, we have some discussion about that. So it's another issue that I think deserves some discussion. And this is about Greece. There were some questions about using it. There were some editorial questions about like, what exactly do you do, ignore it, etc. And we've put those in. And why do you need this? And the reason you need this is you use it or you lose it. This is a long and bitter experience in TLS. So Greece was introduced into TLS for this reason. It's a good idea. It prevents you from having situations where you have intolerant firewalls or other middle boxes that prevent you from extending the protocol further. And then we have one or two more issues, I think. So someone can talk about slow signatures. We've really tried to pick the fastest one. RSA would be even faster, but it's much slower signing, so that's not a great choice. And we're talking about one additional signature verification. It's not a huge burden. Although obviously if your application is different, it might be a burden. I would really like to know more about your application and understand what we can do to speed it up. And there's two more. All right, there's also a question about using the only timekeeper. So I don't think there's protocol changes we need to make. I think it should just work like Ntp. We can't really put in a sent time because, especially after signing, because that just won't work. But we need to do some experiments to really see how bad the result is. It's not going to be as great as Ntp, but we really need some experiments to see. There's also a question about leap seconds and DTI minus UTC and sort of the unnecessary. So there, the leap seconds are, so the thing is they're optional tags for both server and client. There's a lack of standardized distributions considers data, and the ITU is recommending that you include these things in time signals. And tie minus UTC is sort of understandable. UT1 minus UTC, a little more exotic, but people do sometimes want it, and the ITU recommends you have it. So why not? It's optional. Well, that concludes my presentation, and if people have questions, I'd love to answer them.
Okay. Does everybody understand how to get in the queue if you wish to speak? I'm not seeing anybody in the queue, so do you have a rough time? So right now there's 2 documents. Do you have a rough time frame of what you want to do next with those 2 documents?
System 1. Yeah. So we have the ecosystem one, and that one is a bit stalled. We really would like input from other people who are running servers or running clients into what they need to see from the ecosystem. The wire protocol one, I think we're going to revise and submit a new version in the next 2 weeks. I would like to note that Eric Klein has said in chat that I suspect we should ask for an early sector review, probably around the same time as the doc is considered ready for working group last call.
Okay. Makes sense. It seemed like a fairly extensive list of issues, so do you think the next revision will be ready for working group last call, or will it? I guess it'll depend on the comments after the revision comes out.
Well, I thought this revision was ready, but turns out there were a bunch of issues covered. So I'm not going to be as optimistic with the next revision, but I do think we can address, because a lot of these issues were editorial, and but I do think if the next revision comes out, it would be nice to get comments from people who still don't agree with the way we've handled some of the issues.
Okay. All right. Thank you. Still seeing nobody in the queue to ask any questions. We will. Thanks, Watson. The next thing on the agenda is the Ntp V5 Use Cases. James, would you like to run your own slides? I think I messed up with Watson. I think he actually asked to run his slides, and then I did it.
I don't mind. Either you share or I share. Your call.
You go ahead.
Okay. You have to accept my screen request.
I thought I had, but I guess double clutching, I hadn't really.
Oh, there we go. Okay, so I kind of lied last IETF meeting, and I sort of, the interim, I can't remember which, I said that I was not going to do any more work on this. But my ability to focus got the better of me, and I did a version 02, which there's obviously been a lot of robust debate about some of the high-level topics, but just about cover what I changed. I have done a very initial threat model on NTP and its usages as a whole, at very high-level stuff. I've added in some NAT requirements, changes to some of the other requirements, and lots of nits and spelling mistakes and so forth. I've also done some other further work after the 02 release that's not published yet, basically restructuring a huge amount of the document. So it's using the IANA and security recommendations as they were supposed to be used. The other thing that I've done since I've last talked about this draft is I sat down and did some analysis on everything that is depended on or referred to RFC 5905, but also the adjacent RFC specifications for Ntp V4 related things. And to understand if there is any sort of dependencies there that may be important when considering Ntp V5. And so the next couple of slides, I'm just going to talk about what I found and leave some ideas for people to have a mull about when we discuss this document and its progressions further. So I found over 80 RFCs. I didn't read all of them at length, but I at least skimmed through what I thought was the most important bits. 10 of them obviously are docs that have come out of this working group. Most are informational. Most are just fulfilling a requirement to say you must have accurate time or you must have a reliable time source. Maybe you should use NTP. But where there are other dependencies on 5905, I've sort of lumped them into three sort of subjects of the usage of date formats of NTP epoch, of metadata and identifiers and service discovery. So I'll just talk through those really quickly. So what I mean by this is I'm referring to the NTP epoch, which is obviously different from Unix epoch, GPS, so on and so forth, and also around the way that NTP represents timestamps, date, and other such information. Turns out that there's quite a few protocols out there that are effectively copying and pasting or referring to directly those formats and are expecting to have those epochs to be used. And so there may be, as a result of this work, some thinking we would have to do around whether or not we decide to change which epoch we use, or, sorry, I'm brain farting out here. Or whether or not the way that the data model around dates and times may be a quote unquote breaking change. The other big users, and these are used by media protocols and also used by by protocols that are used for performance or at least latency measuring, jitter measuring of networks as themselves. And this is probably because a lot of these implementations are not only doing these measurements, but they're also using NTP services to generate those values. And there's some thinking we're probably going to have to do when getting around to the design of V5. The second one is metadata and identifiers. There's a few documents out there. They're mostly Yang related. I don't see any huge issue with NTP V5. And these, obviously, we will have to consider doing a Yang model for Ntp V5 if it's substantially different or regardless. And the last one, service discovery. Ntp V4 doesn't really have a DHCP version 4 option. It does have V6, which is 5908, and there isn't a ICMP V6 RA. And so there will be a kind of an orthogonal question about whether or not we need to potentially do a document that defines DHCP/IPv6 RA options for Ntp V5 in the future. We don't have to answer that as part of the protocol design, but there may have to be a consideration about what information would be included in the option. So what's left? If you ask me, and we haven't even adopted this document left, there's only a small handful of things that I think need doing apart from a bit better editorialization. I think that there's a bit more work that needs to be done on the threat model, a bit more covering rate limiting, data minimization, And I would also open it up to discussion about whether there's anything else this document is lacking. Every time I've posted on the list a new version, we seem to end up going down the road of talking about either timescales, leap seconds, or mandatory security or not. And I've said this in the past, and I'll say it again. Those things are still up for negotiation, and what I'd like to do is have this adopted as a working group document, so that those quite frankly controversial things can then be sort of bound by working group consensus as a means of attaining agreement, rather than it just being an individual document and me being able to put whatever I want. So that's it. Is there any questions or fruit to throw at my way?
While we're looking for any questions, the one thing that you mentioned was that it has not been adopted, and I think now that we're pretty close to having an updated charter, I think it probably makes sense to go ahead and do a call for adoption on this document, unless somebody has a reason why we shouldn't do that. Boy, you guys are really quiet today.
Before the call for adoption happens, I would like to crank out one more version before that happens. Oh, hello, Doug.
Hello. So you mentioned sort of the top three things that people love to debate about this, and one is the security thing, and you do have statement in there here about making security mandatory, but really not much else. I wonder if it'd be worth the, and I'm not saying we shouldn't adopt this as a working group document anyways, but some kind of elaboration, like how would that look in the requirements document? If it's not enough just to say security should be mandatory, we need to have a little more discussion on, like, okay, it needs to be, one of these mechanisms, or how does that look?
So there is a bit more than just saying security is mandatory, and I think that there's been a jumble up even on my side about the language that is used to describe it, because I think some people have conflated confidentiality with authentication. One of the things I've tried to be adamant about is it's my preference that the protocol have mandatory authentication, but optional confidentiality. And then in terms of how that is implemented, well, I'm open to, I don't think that's a solution, and I think that the requirements draft shouldn't be overtly descriptive about what that solution is. I think the consensus that I've understood so far is, maybe it should just use NTS, because it's there and it works. I'm not sure what else needs to be elaborated on that topic, aside from the threat model that I've started to work on, which the outcome of it, which includes both the risks and what I believe potential mitigations in the protocol, which thus become requirements. If there's anything else there that should be part of it, can you give me maybe a bit more of a specific example of what you mean by more detail?
Well, I'm thinking about someone wanting to do maybe some kind of lightweight security for simple devices. What would be the minimum requirements?
Well, that would come down to the actual protocol specification. What we agree for would be the actual technical solution. If there's think about the best way of saying this. If there's performance requirements in terms of thinking about embedded devices or, power, compute bandwidth, crypto constrained requirements that you think should be part of it. It'd be good to know what those are. I'm not sure that answers your question.
Yeah, and I don't have something in mind. I'm just thinking there might be a little more detail on that. I'll think about it and maybe post something on the reflector.
Okay.
One question, James, you said you wanted to do one more spin of the document before we did a call for adoption. Do you have a rough time frame for when you expect to do that?
I could definitely have something done before the next IETF meeting.
Okay. Go ahead, Rich.
What kind of things are you planning to do, and is there any reason why it couldn't be adopted and then done with the working group looking at it?
So my biggest concern is just the structure of the document. I've restructured it quite a fair bit in the past couple of weeks. Maybe what I can do is just publish the restructured bit, maybe with one or two small changes, push that out as an O3. We can do the call for adoption, and assuming that the working group has no objections and chooses to adopt it, then I can carry on with the rest of the other changes in my queue of things I'd like to do.
Yeah, I think I'd prefer to do that.
Difference between waiting and is, post the list of queue items you want to get to, and see if after adoption. I would encourage you not to wait until March.
No, what I can do is I can probably have a crack at tying things off this weekend, because I have a whole bunch of other IETF related chores to do, and then maybe sort of next week or the week after have something actually published. Does that sound a bit more timely?
That sounds much better to me, anyway.
Okay.
Yeah, I would prefer that as well. I'd like to see us get to consensus on this document pretty quickly because we have some stuff queued up behind it.
Okay, yeah,
All
I'll try and get something done in the next week or so, and I don't like making promises like that, but okay.
All right, thank you, James. So the next item on the agenda that I have is Ntp V5. We do have an updated document. We don't have a presentation. I'm not sure if there's anything. Miroslav, do you want to say anything with respect to this or just ask for additional comments on the mailing list? Here you come.
Hi, can you hear me?
Yes.
Okay, great. Yeah, the latest version, there was just one small change. There was a suggestion from Doug. There are no real changes in the protocol, and I think the dependency here is on those requirements that are still not clear, and I would ask for making those requirements clearer, as Doug commented on, specifically about the security part, like my draft, does it meet those current requirements or does it not? I'm not sure. Yeah, that would be nice if I could see how my draft fits into those requirements. And maybe it's just my observation. It seems to me that there are two groups of people and they are pulling on opposite sides of the rope. Like one group seems to me is interested in extending the use cases that are currently exist for Ntp V4, but the other group is trying to restrict them, like make one proper way to use NTP, be it fully secured or not secure, I don't know. And I suspect there will be no consensus reached on one set of requirements. So maybe if it would make sense to split this effort, like one true proper NTP for the future and one that's trying to fix NTP V4, and it doesn't have to be called NTP V5, it could be something else. Yeah.
Yeah, that's a. I think you're true. I think you are correct that there are difficult to resolve differences of opinion right now on what NTP V5 should do. What the solution to that is, I'm not really sure. That's why I'd like to see that requirements finished sooner rather than later. Yes, Doug.
Yeah, just a comment. I wanted to say I really like that the way leap smearing is made transparent in this proposal, because I think hidden leap smearing is just a catastrophic data center failure that's waiting to happen as more and more data centers are becoming more dependent on precise timing, and they all tell me they want to do leap smearing like Google does, and I just think that it's making it visible is way better than pretending it's not going to happen.
Go ahead, Miroslav.
I have no comments.
Oh, okay. You showed up in the queue. I thought you had something additional to say. Okay, so everybody please take a look at the Ntp V5 draft that Miroslav has, and also take a look at James's draft and think about how we can figure out a way forward for these. If there's nothing else on that, the next topic is NTP over PTP. Miroslav, did you want me to share slides, or are you going to do it? Oh, you're doing it already. Never mind.
Can you please share them?
Share the button. Click the button. Oh, sorry, I hit the wrong button. Can you do it again? So many little tiny buttons. Oh, you want me to share them? Sorry, I will do it.
Can you hear me?
Yes, I can.
Okay. Yeah, just a short presentation. First slide, please. Okay, so with any time synchronization protocol like NTP or PTP, accuracy of the synchronization depends on how accurate are the timestamps of the messages that the protocol is using. Absolute accuracy is not as important as symmetry in the errors in the receive and transmit timestamps. If the errors are symmetric, they cancel out in the calculation of the offset. But the error needs to be stable to enable a stable synchronization of the clocks. On a computer running a software implementation of the protocol, there are a few different places where the timestamps can be captured. Application timestamps are least accurate, kernel and driver timestamps are more accurate, and most accurate are hardware timestamps. That's when the networking controller has its own clock for timestamping. Usually it's implemented in the MAC At the physical layer, it's much more accurate. It's close to the actual wire or fiber, but this is very uncommon, especially at the higher networking speeds. Next slide, please. Here is an example of errors in kernel and driver timestamps. As we can see, they are not really randomly distributed, and they are all kinds of banding that depends on networking load, CPU load, and all kinds of things. Next slide. Now, this is an example of Mac hardware timestamps. The absolute errors are now better than 1 microsecond, and they are very stable. There is an asymmetry, but this can be compensated in software if necessary. Next slide, please. The problem for NTP is that some widely used networking cards cannot timestamp all received packets. It's a limitation in the hardware design. Usually the timestamping is limited to PTP messages. Sometimes the filter can be configured to a specific PTP version, transport, or message type. Support for NTP is very rare. I think I saw only one chip that actually had a filter specific to NTP. As for the transmission, usually any packet can be timestamped. It's not an issue. Next slide, please. Okay, so the solution for NTP is obvious. We can wrap NTP messages in PTP messages. This way, the hardware will generate the timestamp, and the NTP implementation can use it for controlling the clock. This is the proposal, uses a valid PTP message. It will not break normal PTP clocks if they receive this message, for example, due to a misconfiguration. There is a possibility to use the PTP correction field, but unicast support in switches seems to be very rare, and currently I don't think it's worth the trouble. Next slide, please. Here is some hardware that I tested. It mostly worked. The one problem was with the 10 gigabit Broadcom card. It seems its PTP support is limited to multicast, so it doesn't work with PTP unicast and not even with NTP over PTP. Next slide, please. Okay, this is one of the controls I tested. It's a cheap onboard NIC that's widely available. There are two identical machines, and they are connected directly without any switches between them. The graphs show the offset measured by NTP. This is the raw offset, not the offset of the clock. It's with plain NTP, we can see the offset is jumping around by tens of microseconds. Not great. But when we wrap NTP in PTP, we get the missing hardware receive timestamp, and the offsets drop by 3 orders of magnitude. There is likely a significant asymmetry in the receive and transmit timestamp that this hardware is generating, but as the hardware is identical on both sides, these asymmetries cancel out, so it's now very close to 0. There is some small asymmetry left, about 10 nanoseconds, as we can see in the graph, and I'm not sure where that comes from. Could be a difference on PCI latency, I'm not sure. There was, in the test, there was the system clock involved for comparing these measurements, so it's even the hardware is identical, something is slightly off. Next slide, please. Okay, this is the same test, but now with a switch between the two computers, and we can see that the switch added few hundreds of nanoseconds of jitter, and there is an asymmetry of about 200 nanoseconds. This is quite common for a cheap switch. This was an office grade switch, nothing in a data center or some low latency application. With a better switch, this would be better, but even as it is, I think it can be great in some use cases. Next slide. Okay, any questions?
Go ahead, Martin.
Hi, thanks for the presentation. I have two questions. The first one is this approach or this protocol only for an internal, for a local network? And the second question is what is the advantage of NTP over PTP instead of plain PTP in the local network? Or if we run it in the local network is the first question.
Yeah, okay, so this is not limited to local networks. If you want it, you could use it over internet. But if you communicate over internet, the latencies are much more variable, and this improvement of microseconds in accuracy of the timestamping becomes insignificant compared to the latency of the internet and the jitter of the internet, typically a millisecond, depending on how close you are to the server. But as for the security, there is no security issue because there is no amplification, so this cannot be exploited even if it was publicly accessible. And if you want it, this is now implemented in Kernel, you could try it. And the other question was, what is the advantage? Well, I think we have discussed this on the mailing list. There are many issues with PTP, the security issues, the amplification, and in many cases, there is a need to account for the errors in synchronization, the concept of root delay and root dispersion that NTP has. PTP doesn't have this concept, so it's difficult to estimate the maximum error. Yeah. I tried to list some of the issues of PTP in the draft. You can look into that if you think that's accurate.
Okay, thanks.
Go ahead. Okay, Doug, go ahead.
Yeah, so just a couple of comments. One is I'm dubious about this over wide area networks because if you go through enough routers, then PTP is not really any more accurate than NTP because the error comes mostly from queuing, not from hardware timestamping at the endpoints. The other comment I wanted to make is I've gotten a lot of input from people in the finance industry they're using PTP because they need the precision of it, but they actually don't like the way PTP works. In theory, you can have multiple grandmaster clocks in PTP and then combine them in a voting algorithm, but none of the implementations do that. And that's sort of the default for NTP, and they really like that that aspect of NTP. So that would be another reason why people might want to do this.
Okay. Go ahead. Nacio.
Sorry, I thinking that Miroslav was to say something.
Oh, that's okay.
Okay, no, just okay. I would like to also to say the same comment. When you are trying to synchronize about internet, you got a several problem. This is one of the problem that I address with the draft that I presented to TikTok. But my question to Miroslav is, you always find the same bias to the transmitter or to the receiver. Nowhere, even if you try to invert the transmitter and receiver, this is just a question about curiosity.
I'm sorry, what was the question?
Yes, but you show that you have some bias in your. It's not symmetrical. I don't remember
Yeah,
if the receiver or the. But if you invert receiver, the machine trying to send the client and the server, if you invert the machines, the real machines, do you observe that the bias is inversed, or you always got a bias in the same idea? It's always imagine the receiver, for instance.
okay. Yeah, I think I tried this experiment to swap the cards. It was different cards, not this one. And sorry, I forgot the result. I think it was something with the machine itself, like the sign of the asymmetry stayed with the machine. That's how I remember it, but I could be wrong. Yeah. I have in those machines there are different cards. They are in the same PCI slots, so the order is the same. The CPUs are configured to the same frequency, so the reading over PCI takes the same time, but there was always some asymmetry. And I think it was slightly different between different cards within few nanoseconds.
Okay, because I used to synchronize microcontrollers, and I have problems with even if the microcontroller seem to be the same, there are always some bias, which normally depends on the hardware, depends on the machine itself, but sometimes it's always in the function. It depends. Just the receiver has always, I don't know, it's always late, for instance, something like that. But well, just about curiosity. Many thanks.
Thanks.
I'm going to go ahead and close the queue for this because I want to get to the last topic. So Doug, if you could be quick.
Yeah, I just when you get below a microsecond, then there's like a lot of well-known asymmetries, like the differences between PHYs, forward and reverse transmission, and cables. If you have long cables, all have skew in them as well.
All right. So Miroslav, do you have anything else you want to say?
No, that's all.
All right. Thank you very much. So we have 5 minutes left. Martin was going to give us a quick update on the progress on the NTS for PTP work.
Yes, hi. Yes, at this point, some information about PTP security. So far, we have two NTS-based draft documents for securing PTP. On the one hand, we have NTS for PTP, which Rainer Bernbach and I are working on. And on the other hand, we have NTS for UPTP, which is developed by Meinberg. We know that two draft documents are not helpful. And therefore, we met this Tuesday and Wednesday to find a common solution which all authors of both proposals. So we worked together, and we had long and constructive discussions on how we want to secure PTP and how we could realize that. I think stands we are going to merge our approaches and design a new protocol. So we will probably use the unicast approach in NTS for UPTP and the multicast approach in NTS for PTP as a template. Currently, we are at the very beginning, and the process is ongoing. So the redesigning of the protocol. The goal is to use the NTS key establishment protocol as the key distribution mechanism for PTP. However, we cannot yet say when the first draft will be ready, but we are making progress. I think maybe in 2 or 3 months, maybe faster. But there's a lot of discussions currently, but we're working together and we won't push one document, one protocol, NTS for PTP. So yeah, so far for the on the topic of PTP security.
Okay, thank you. We look forward to the updated draft. So that update went really quick. So that brings us to any other business. We had, out of our last meeting, we had agreed to do virtual interims, which we did not do. Given what some folks have said about when they plan some updates, I was thinking perhaps a virtual interim in the mid-January timeframe might make sense. Does anybody have any thoughts on that? I do think we make faster progress when we have virtual interim meetings. And it also gives us more control over scheduling. Go ahead, James.
Provided they don't clash with all the other interims that I have around the middle of January, sure.
Oh yeah, there is that. Okay. Anything else? Go ahead, Rich.
Forced update to my computer, which rebooted. What happened at the beginning with the registry draft? Updating the registry?
I asked if there was any opposition to doing a working group last call, and there was none, so I expect one will be issued.
Thank you very much.
All right. Anything else? My goodness, we're going to end pretty much exactly on time. Thank you, everybody, for coming, and we will see you at the next meeting. We are done.
Thank you and bye.
Bye, Martin.
Bye, Martin. Okay. Bye, everyone.
Goodbye, Dieter. I'm going to hang up now.